Hello all, and welcome to the Algebra 1 video for the topic of solving and graphing inequalities. Okay, so at this point this should maybe be a little bit of a review to guide us into what we'll be going to later on. But in this case, solving and graphing inequalities, we're kind of going to do it a little bit backwards here, okay? So first things first is we're going to actually go through and learn how to graph inequalities first, okay? Because what we're going to be able to do is once we know how to graph inequalities, when we solve inequalities, we'll be able to graph their solutions, okay? So with that being said, first thing we're going to talk about are rules for graphing inequalities. Okay, so once again, this should be a little review, maybe a little, maybe you should have heard of this before, but if not, just make sure to pay attention and copy this down on the notes here. But whenever you're graphing inequalities, you use an open circle for less than signs or greater than signs. Okay, less than sign. Might have heard these referred to as hungry alligators. The hungry alligator always wants to eat the bigger side, so it opens its mouth to the bigger side. Well, in this case, less than symbol means whatever's on the left is less than, meaning it's littler than whatever's on the right. So the alligator wants to eat what's on the right. The opposite side of things, if it's a greater than symbol, then whatever's on the left is greater than or bigger than whatever's on the right. Okay, and once again, the alligator opens its mouth to the left, which I'm going to drop that analogy, but like I said, that might be maybe how you've heard or know about the inequality symbols before. So if that helps you remember or helps you understand what these mean, that's perfectly fine. Okay. Now, when we say open circle, as we'll see here in just a few seconds, what that means is when we actually graph on the inequality, we'll actually want to use just an open circle, meaning a circle that's not filled in. Okay. Now, on the other side of things, when we're graphing an inequality that is less than or equal to or greater than or equal to, okay, big key here is or equal to. That's what this little line underneath the less than and greater than signs mean. We would use a closed circle, meaning you use a circle that is filled in, so like a dot, okay? And the difference here is with an open circle, we're saying, okay, the thing on the left cannot be equal to the thing on the right, meaning it has to be strictly less than, okay? When I say strictly less than, means it can't be equal to. If we say it could be equal to, that's when we use the greater than or less than signs, meaning it has this line underneath it, meaning whatever's on the left could be equal to whatever's on the right. So that means we use a closed dot. Now, to see that in practice, let's go ahead and get into the examples, okay? So when we look at number one, example number one here, we have x is less than 3, okay? X is less than 3 means whatever x is, okay, it has to be littler than 3. So what we would do here is we first ask ourselves, can x be equal to 3? Well, if we think about it, 3 is not less than 3, okay? So in this case, we can't have x be equal to 3 here. So in that case, that means we're going to use an open circle, and we're going to be directly over the 3. Now, normally you would draw this actually on the line, but just for simplicity's sake and just so everybody's clear of what's happening, the circle is on 3, okay? And then we need to draw an arrow. So we have a number line here. If we're at 3, well, you can see with the number line, normally the numbers as you go to the right get bigger. The numbers as you go to the left get smaller and even go into the negatives, okay? So in this case, what numbers would work here? So think of a number. Is it less than 3? Well, in this case, 2 is less than 3. 1 is less than 3. 0 is less than 3. Negative, basically any negative number is less than 3. But if you go to the other side, 4 is not less than 3. 5 is not less than 3. So what that tells us is we need to draw an arrow to the left. And once again, that means we have every number, open circle means x is not equal to 3, and then every number to the left of 3 works in this situation. So 0, -1, -2, -3, -87. Okay, once again, whatever number you can think of that is to the left on the number line of 3 is a solution. So once again, that's what this means. When we graph it, we say all numbers to the left of 3, not including 3. That's what the open circle means. Number 2, same kind of thing. X is greater than -1. Well, in this case, we look at where -1 is. -1's right here. So in this case, x cannot be equal to -1. So we have, once again, an open circle. But then this time we got to think, well, we want x's that are bigger than -1. And if you're very clever and you think about the number line, we said numbers are always bigger when you go to the right on the number line. Same here. Numbers are always bigger when you go to the right. So 1 is bigger than -1. 2 is bigger than -1. 0 is bigger than -1. 5 is bigger than -1. 87 is bigger than -1. So you keep going out here forever. So actually every number that's to the right on the number line actually gives us a correct answer here, okay? So once again, the way we graph that is we put an open circle at -1 since x cannot be equal to -1, and then we draw a line to the right because that is the direction where numbers are bigger than -1. Number 3, same kind of thing here. We want x to be bigger than or equal to 7. So once again, we find where we're at. So we're talking about the number 7. So we go to the number 7 on the number line. In this case, we're actually going to use a closed circle. Okay. And once again, why we use a closed circle here is, can x be equal to 7? Well, think about what this means. X is greater than or equal to 7. So x actually in this case can be equal to 7. So we indicate that by drawing a filled-in circle here. Now, once again, filled-in circle, okay, put it in the same spot we would an open circle. So we just put it where the number is that we have here. So x is greater than or equal to 7. So that means we start at 7. In this case, we want the numbers that are bigger than 7. So once again, get better with this and get quicker with this as you go. That means we want to go to the right. We want numbers that are bigger than 7. Well, numbers that are bigger are always to the right. Okay. And lastly here for this type of question, if we have x is less than or equal to -5, same kind of thing here. We start at -5. X is less than or equal to -5. So we draw a closed circle at -5. In this case, we want the numbers that are less than -5. And once again, if you really think about it, all numbers to the left are less than the number you start with, okay? So the arrow has to go to the left. And that's pretty much it in terms of graphing inequalities. Now, the next set of examples is going to kind of work in reverse. You're going to be given a graph, so you're going to look at the graph and based on what the graph is, tell what it's saying about the inequality, what inequality we have. So if we look at number 5, once again, we don't know what the inequality is. We need to look at the graph to tell what it is. So here we can see we start at -2. So what I would do is I would go ahead and write down, we're starting at -2. Okay, so write down the number -2. In this case, you see an open circle. So you know you're either dealing with less than or greater than, okay, because we know that x cannot be equal to -2. So that's what I would write down next is x, okay? But now we need to figure out what sign we need, okay? But in this case, we need to just look. What numbers are we pointing to with the arrow? Well, at -2, we're going to the left. So that means at -2, we go look to the left. Those are all numbers that are less than -2. So the answer here is x is less than -2. And if you did want to check yourself, double check. Okay, think about what's being said here. x is less than negative 2. Well, that means you want numbers that are less than negative 2, so to the left of negative 2. So the arrow is open because we don't have an equal to here, and the arrow points in the correct direction, meaning we do, in fact, have numbers that are less than negative 2. Okay, negative 3, negative 4, negative 5, negative 6, negative 7. All the way out there to negative 87, negative a million. Okay, any of those numbers are less than negative 2. Number 6, same kind of thing. We see where we start. We're starting at 4, so I would go ahead and write 4. We know we're dealing with x, or technically it doesn't have to be x, but just for good practice, we normally use the variable x here when we're dealing with a number line. But now we need to know what the sign should be. Well, right off the bat, we notice there is a closed circle, so we know it's either going to be less than or equal to or greater than or equal to. Okay, so which one is it going to be? Well, we need to look. What numbers are the arrows pointing to? Well, the arrow's pointing to the right, meaning numbers that are bigger than 4. So we want numbers that are greater than or equal to 4. And we can't forget that or equal to, because once again, that's what's signified by this closed circle. Okay, so x is greater than or equal to 4. Number 7, very similar here. We see we're starting at 0, so 0 is the number we're starting at. Once again, x is going to be in some relation to 0. Well, what relation is that? Well, once again, it's going to either be less than or equal to or greater than or equal to. And the way the arrow is pointing gives us that indication. So what way is it pointing? It's pointing to the left, meaning it's pointing to numbers that are less than 0. But once again, where it's closed circle, it's not simply less than, it's less than or equal to. So numbers are less than or equal to 0. Okay? And then lastly, this number line, you see we're starting at negative 3, so we know negative 3 is the number. X, okay, well, what is x what's going on here? So once again, open circle meaning less than or greater than. Okay, we know it can't be negative 3, but then it's pointing to the right, so that means we want numbers that are bigger than negative 3 or greater than negative 3. Okay, and that's pretty much all there is to graphing inequalities. Now, how are we going to use that? Well, we're going to use it because when we solve inequalities, we want to be able to graph the solutions. We want to be able to know, well, what numbers are we talking about when we solve an inequality? So that's what we get into next with rules for solving inequalities. Well, I'll go ahead and tell you, the rules for solving inequalities are the exact same as the rules for solving equations, except for one big rule. Okay, and this is one that on your paper, in your notes, whatever you need to do here, put stars by it. You see I've got all these underlines and exclamation points. This is the big thing. This is really the only difference between solving inequalities from solving equations. Everything else is exactly the same except for this. And what changes is you must flip the inequality symbol when you multiply or divide by a negative number. Okay, and my note here says to see example 11 because that's where you'll see it in the examples the first thing. But I do want to be very clear. It's when you multiply or divide by a negative number. So here, if I take 5 and divide it by 1, or let me think of a different example here. If I take the number 10 and divide it by 2, I'm dividing by 2. This is dividing by 2. Okay? If I do it with a negative, if I do 10 divided by negative 2, this is dividing by negative 2. So in this situation, when you divide by the negative 2, that's when you would flip the inequality. Okay? Same thing happens with multiplication. If I do 10 times 2, this is multiplying by 2. Okay? But in the other way, when we do it this way, multiply times negative 2, that's multiplying by negative 2. So once again, where we would flip the inequality sign is when we multiply by the negative. And like I said, when we get to example 11, I'll make sure to point this out. But that's the only difference. Everything else in solving inequalities is the same as solving equations. So to look at that, let's go ahead and look at number 9. Okay? So we have 3 times x plus 2 is less than negative 4. Well, if I replace this less than sign with an equal sign, I guarantee most of you would be able to solve that no problem. That's just a 2-step equation, okay? But I do want to point out those same steps that we use to solve the equation, okay, are the same steps we're going to use to solve the inequality. So let's leave the equal sign there for now. 3x plus 2 is equal to negative 4. Well, once again, I'm not going to go through every single step here like it's the first time of you seeing this, because at this point you should know how to solve 2-step equations. But our first step would be to subtract 2. If we do it to one side, we got to do it to the other. So the point here is those go away. We get 3x is equal to negative 4 minus 2 is negative 6. Well, what's the next step? Well, as always, we want to do the opposite of multiplying times 3, so we divide by 3. So we get x is equal to negative 6 divided by 3. That is negative 2. Okay? But I do want to point out something big here. This isn't an equation. This is an inequality. So if what you could do is go through here and say, okay, that's not an equal sign. What was that? That was a greater than sign. Here, I've subtracted 2, so this is still going to be a greater than sign. I divided by a positive 3, so it's still going to be a greater than sign. So our answer here is actually x is less than, I keep saying greater than, I apologize for that. It should be less than, okay? So our answer here is actually x is less than negative 2. And based on what we just did in the previous examples, now we need to graph that answer, okay? So just like we did before, if you've got a number line, in this case, we'll have to actually label some points. So I'm going to put negative 2 here, and then negative 1, 0, 1, 2, 3, 4, 5, 6, okay? And then we have negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Now, you don't have to be as thorough. As you'll see, I'll cut it down. I'm not going to label every single point over here. And I'm fine if you don't label every single point. But we got to know, where do we start? We start at negative 2. Can x be equal to negative 2? No. So we use an open circle. Okay? The open circle tells us x can't be equal to negative 2. But what numbers do we want? We want numbers that are less than negative 2. So those are numbers to the left of negative 2. So our arrow goes to the left. So that means we're talking about numbers like negative 3, negative 6, negative 8, negative 10, negative 87, negative 1,000,000. Okay. What that's telling you when you look at this graph is you're saying, okay, any number that I pick that falls under this arrow, if I plug it back in, it will work in this inequality. Okay. Now, just like equations, if you wanted to, pick one of these numbers. So just picking one that maybe is easy to calculate here, something like negative 10 or negative 20 or something. But if you plug it in, you can check. So plug it in, do order of operations. What you get on this side should be less than negative 4, okay? But once again, the steps here, just the same steps, okay? that you use to solve the equation are the same steps you use to solve the inequality in this case. Same thing happens with number 10. X divided by 6 plus 2 is greater than negative 1. Well, the first step here is going to be we're going to subtract 2. Those go away, so we have x over 6. X divided by 6 is greater than negative 3. Okay, once again, this is subtraction by 2. So what's the next step? Well, we're dividing by 6, so we need to multiply both sides by 6. The whole point here is those go away, essentially giving us 1x. We multiplied by a positive. Okay, so that means we're going to stay as greater than. Negative times a positive is a negative. 3 times 6, 18. So the answer here is x is greater than negative 18. So same kind of thing. We go over here to the number line. I'm going to put negative 18. Somewhere over here we have a negative 18, negative 19, negative 20, negative 21, negative 22 over here. Negative 23, negative 24, negative 25. And once again, you don't have to label every single number out here. Just as long as you know, okay, here's negative 18. Well, what's some numbers to the left? What's some numbers to the right? Over here, we got negative 18, negative 17, negative 16, negative 15, negative 14, negative 13, negative 12, and then so on, okay? But what we need is we're going to go to negative 18. X cannot be equal to negative 18, so we draw an open circle. And then we want numbers that are bigger than negative 18, and numbers are always bigger to the right. So once again, the solution or solutions, the solutions to this inequality are any number that's bigger than negative 18. So negative 15, negative 12, negative 10, 0, any positive number, okay? So once again, this arrow means it goes on forever. Those are all solutions to the inequality. And once again, if you pick some numbers over here, pick a number or two, and plug it back in and do order of operations, whatever you get on this side is going to be bigger than negative 1 if you pick a number to the right of negative 18. All right, so number 11. This is the big one, so if you want to put stars by it, this is the one I was warning you about in the previous slide there, okay? This is where we're going to have to deal with flipping inequality. Notice I haven't mentioned that in the previous two examples, but solve it like you're solving an equation. So first step, subtract 8. Since we're just subtracting 8, okay, those go away, so we still have negative 7x. Since we're just subtracting 8, it's going to stay the same. And 1 minus 8 is negative 7. Okay, so once again, this stays less than or equal to from here. But the next step actually shows us why we need to flip. Because what are we going to do? Well, we're multiplying times negative 7 to the x. So we need to do the opposite. We need to divide by negative 7. But once we do on one side, we got to do the other. But here is the whole crux of the situation here. We divided by negative 7. Those go away. So we have x. Negative 7 divided by negative 7 is a positive 1. But what did we just divide by here? We divided by a negative. Okay? So right here, we divided by a negative. So that means, since we divided by a negative, based on the rule that we talked about in the first slide for this second little section here, is we have to flip the inequality around from less than or equal to greater than or equal to. So if you need to, actually write the word flip in here. Give you some sort of visual indication that you flipped the inequality, okay? Because sometimes when people look at this, they just forget. Okay, but like I said, this is the main thing about this section. This is the main thing that makes inequalities different from equations in terms of how you solve them. So our answer is actually x is greater than or equal to 1. Okay, so just like before, we go over here, we have 1, 2, 3. You don't have to do all the numbers. You have 0, negative 1, negative 2, negative 3. Okay, so we're going to start at 1. Okay, we can go out to 4, let's make it even. Go out to 1, okay? And then we're going to do a closed circle because, once again, x can be equal to 1. But we want numbers that are bigger than 1, so our arrow is going to go to the right. Now, if you forgot to flip, what's that going to mean? Well, that's going to mean your arrow would have went in the other direction, okay? Meaning your arrow would have went to the left. Well, we can actually just check a couple numbers here. What if we had 0? 0 is to the left of 1. Negative 7 times 0, 0. 0 plus 8 is 8. 8 is not less than 1. Okay? So that means if you were to check it, if you had your arrow to the left, you know something was wrong because 0 isn't an answer. Okay? But if we go to the other side and let's pick 2. Well, negative 7 times 2 is negative 14. Negative 14 plus 8 is negative 6. Negative 6 is less than or equal to 1. So that tells us that we did draw the arrow in the correct direction. But like I said, here we divided by a negative. We divided by negative 7. That means we flipped the inequality. Okay? I do want to point out over here. Here we had a negative in the top, but we divided by a positive. Here we had a negative to start off with, but then we multiplied by a positive. So the only time you flip is when in the process of solving, one of your steps is multiplying or dividing by a negative. We see the same thing with number 12, okay? So if you want to put stars by number 12 here, okay, both of these are very similar except for the steps just change just a little bit. Here we're dividing x by negative 8, then we're subtracting 5. So that means we need to add 5. And since we're adding 5, those go away. So x divided by negative 8 is still going to be less than negative 2 plus 5. That's 3. So we didn't flip the sign yet because all we did was add 5. But now, since we're dividing x by negative 8, we need to multiply times negative 8. So we got to do it to both sides here. Once again, the point here is the negative 8's cancel out here, leaving us with 1x. Positive times a negative is a negative. 3 times 8 is 24. But what's our sign going to be? Well, what did we just do right here? We multiplied by a negative. Okay? We multiplied by a negative, meaning we have to flip the sign. So if you need to, draw a little flip in there, do something to just show you that this is a situation where we flipped it. Well, what did we do that deserved the flip? We multiplied times a negative 8. So our answer is actually x is greater than negative 24. So same kind of thing here. Come over here, negative 24, negative 23, negative 25. Honestly, I'm good with just 3 numbers here. But we're going to start at negative 24. We're going to have an open circle. And then we want numbers that are bigger. So we want numbers to the right. So numbers like negative 23, negative 22, negative 20, 0, any positive number. Okay. And once again, what that tells us is any of these numbers to the right, if we plug it in here, it will make this true. Okay. So continuing on here, same kind of deal. I'm going to assume that you have a mastery of solving two-step equations, so I'm going to go a little quicker here with the rest of these. I'm just going to list out what I'm doing here. So I'm going to add 5. Negative 2x, since we're adding 5, is still less than 19 plus 5 is 24. Once again, that's to get rid of the 5s. So we have to divide by negative 2. Those go away. X, positive over a negative is a negative. 24 divided by 2 is 12. But what do? We divided by a negative. Okay? So that means we have to flip. So instead of less than or equal to, it's going to be greater than or equal to. And then same kind of thing. We go over here to negative 12. We have negative 11, negative 13, and so on and so forth. But here we're going to have a closed circle at negative 12 and our arrow, once again, pointing to the right because we want numbers that are bigger than or equal to negative 12. So numbers like -11, -10, 0, any positive number. Number 14 is a little bit of a wrench here, but same way we solve the equations like this, we're going to solve the inequalities. So in this case, we have 3 minus 4x. Technically, what you could do here is write your subtraction as addition. And now, since this is addition, you can flip the terms. So I'm kind of glossing over this, but if you did this with two-step equations, then it's the same thing with two-step inequalities, okay? And now we see first step we need to do is subtract 3. Negative 4x is less than 28. Now we divide by -4. So x, okay, which is what we want over here. We want a positive 1x. We just want an x because those will go away. Positive over a negative is a negative. 28 over 4 is 7. But here, once again, what do? We divided by a -4. So we had to flip the inequality, meaning it went from less than to greater than. Okay. So once again, we start where the number is here. So -7, -6, -8. Okay. In this case, we'll have an open circle because x cannot be equal to -7. And then once again, our arrow goes to the right because we want numbers that are bigger than -7. Okay. Now we come into a couple questions here that, once again, people may stumble with a little bit because of the fractions, but the way we handle fractions with inequalities is the same way we handled fractions with equations. Multiply by the reciprocal, okay? So just to give everybody a hint here, with these, you're going to be using the reciprocal, if I could spell. Okay, so don't forget to use the reciprocal. Works the same as before. So once again, I'm going to kind of gloss over this real quick because I don't want to take up too much more time here. But because once again, it's the same steps. The only thing we have to worry about here, we subtracted 5, so that's going to be 6. We keep the sign the same because what we just subtracted 5. Here we multiply times 4/3. So we got to do it to the other side. Well, that's multiplying times a positive 4/3. So the whole thing here cancels out. So that's x. We multiplied times a positive, so it's going to stay greater than 6 times 4/3. Once again, we would go through and multiply out like this. So we'd make our whole number into a fraction. 6 times 4 is 24. 1 times 3 is 3. So we can simplify that. X is greater than 8. So same kind of thing. 8, 9, 10, 7, 6. Okay. So once again, it doesn't matter. We just need to know where we are on the number line. We're going to have an open circle. And it seems like we're on the run with this, but just the way it works. X is greater than 8. That means we need numbers that are bigger than 8. Those are to the right. Okay. So once again, same deal that we've been working with here. Same way we did the two-step equations like this, we do two-step inequalities like this. Now, number 16, we run into a little bit of an issue. First, we're going to add 1. So we get -5/6x is greater than or equal to 15. Okay, so the 1's go away there. So -1 plus 1, those just cancel out. So we have -5/6x is greater than 15. But here, we need to remember the reciprocal of a negative fraction is actually also negative. So here we have to multiply both sides by -6/5. So once again, the whole point here, negative times a negative is a positive. 6 times 5 is 30. 5 times 6 is 30. So that's a positive 1x. Here we multiplied times a negative, so our sign actually has to flip. Okay, once again, if you need to, write the word flip there. Write something in there that indicates to you that you had to flip here. But then we go through, now this one's a little bit trickier because bigger numbers here, but we can do a little trick. We can see we have a factor of 5 on the top, so if we divide 15 by 5, we get 3, but we also have a factor of 5 on the bottom. So technically all we have to do to multiply this out, and you can double check this on a calculator, is 3 times negative 6. So positive times a negative is a negative. 3 times 6. Our answer is actually negative 18 here. Okay, or our number is negative 18 here. So that means our answer for the whole thing is x is less than or equal to negative 18. So we go to negative 18. Over here we got negative 17. Over here we got negative 19. And we're going to have a closed circle. Okay. And the number has to be less than negative 18, meaning our error this time is going to go to the left. Okay. So once again, same exact steps, just remember, multiplying or dividing by negative, that's the only difference. Okay. Number 17 and 18, actually, I think these get a little easier because they are just like numbers 13 and 14 and 11 and 12 and 9 and 10, okay? Just solving two-step inequality. So we're going to add 2. 5x is less than or equal to negative 7 plus 2 is negative 5. Divide by 5. Divide by 5. That's a positive 5. So we're going to get x is less than or equal to negative 1. Negative over a positive is a negative. 5 over 5 is 1. Our answer is x is less than or equal to negative 1. So over here we go negative 1. Over here we got 0. Over here we got negative 2, and then so on and so forth. Once again, this is a number line, goes on forever. But here we're going to have a closed circle, okay, because x can be equal to negative 1, but here we want numbers that are less than negative 1. So numbers like negative 2, negative 3, negative 4, negative 87, okay? Once again, it goes on forever. That's what these errors mean. It goes on forever. So any number that you can think of that's less than or equal to negative 1, that's what the dot means here. So we can plug negative 1 up in here, and it will still work, okay? But that's what this error means. It tells us any number to the left is our solution. Number 18 works very similar to number 14 in that we have 6 minus x here. So if we need to, we can rewrite this. I'm going to include the 1 here just so we can be pretty consistent with it, because technically there should be a 1 in front of the x. So when we flip it around, we would have negative 1x plus 6. And then from here, regular old two-step inequality, minus 6 minus 6. So those go away. We get negative 1x is less than or equal to 8. Divide by negative 1, divide by negative 1. We just divided by a negative, once again, so that means we need to flip. So it's going to become greater than negative 8. And once again, we go over here, negative 8, negative 7, negative 9. Both ways go on forever. But in this case, we're going to have a closed circle, and we want numbers that are bigger than negative 8. So that means our error is going to go to the right. And the last two here, okay, once again, a little trickier as we went on, but if you were able to do these in terms of a two-step equation, it works the exact same as two-step inequalities. Just remember if you divide or multiply by a negative. So same thing here. I'm going to take a little bit of a shortcut where, once again, all I'm doing is rewriting this to have this in the same form, and then we just solve like normal. So minus 4, negative 1/3 x is greater than 7. Multiply times negative 3 over 1, so multiply times the reciprocal. Multiply times the reciprocal. Those go away, leave us with x. We multiplied by a negative, though, so instead of greater than, this is going to be less than. Positive times a negative is a negative. And if you're clever, you don't have to do the whole fraction thing here, because you can notice 3 over 1, that's just 3. So 7 times 3 gives us 21. So we get a negative 21 here. So x is less than negative 21. So negative 21, negative 20, negative 22 over here. We're going to have open circle, and then we want numbers to the left. So we want numbers less than negative 21. And then to wrap this all up, once again, it's kind of a special case here, if you remember, to give you a hint as to how to deal with this. X plus 11, that whole thing is being divided by negative 2. So that actually means our first step is actually to multiply times negative 2. Okay, because once again, order of operations tells us, all right, well, we need to deal with addition and subtraction before multiplication, but if we draw these parentheses in here, the fraction bar kind of acts as a grouping symbol. So actually, we take care of stuff in parentheses or grouping symbols last. Okay. Also, if you think about it in terms of, okay, what am I doing to x? Adding 11, then dividing by negative 2. So that means to solve this, I need to multiply times negative 2, and then I'm going to subtract 11. So we multiply times the negative 2 to give us x plus 11. Negative 2 times negative 2 is a positive 4. But here we got to pay attention. What did we just do? We multiplied times, I didn't write it up here. We flipped it. So here we got to flip it too. Because what do? We multiplied times a negative 2. So instead of less than, that's greater than. And now we just solve it like normal. Okay, in this case, it becomes a one-step inequality of subtracting 11 from both sides. So x is greater than negative 7. So same as always. We go to negative 7. There's negative 6, negative 8. We're going to have an open circle at negative 7, and our arrow is going to go to the right because we want numbers bigger than negative 7. Okay? And that's pretty much it. So just be aware, pay attention on the homework if you run into something like this or run into some fractions. But once again, they work the same way. The only thing you have to worry about with an inequality over an equation is flipping the sign, meaning greater than becomes less than, or less than becomes greater than, if you multiply or divide by a negative, okay? So that's what I say. If you need to write the word flip or do something, write something here, do a star, it doesn't really matter, whatever helps you, just to indicate, hey, I had to flip here. Why? Because I multiplied times a negative, okay? But other than that, it's a matter of, after you get the answer, graphing it. And once again, what does an inequality really mean? Well, we just want numbers that we can plug in that make something less than or bigger than a number. In this case, like with number 20, we want the left side of the equation, or left side of the inequality, to always be less than negative 2. And when we solve the inequality, that tells us all the numbers that we pick. So if we pick any number greater than negative 7, it will make this true. Okay? So kind of a rundown, a little review on inequalities there. Use the examples we just did to complete the homework. I think there's only 12 homework questions in this section, so kind of light on the homework. But once again, make sure you're showing all your steps. Make sure that you're indicating or that you know when to flip an inequality sign. Because like I said, that's the main goal, main thing of this whole section is what makes equations different from inequalities when you solve them. Flipping the sign. Okay, and what causes that is multiplication by a negative or division by a negative, as we saw in number 18 here, or number 14, or number 13. Once again, dividing by a negative or multiplying by a negative, like number 19 or number 20. Okay. But other than that, just make sure you pay attention to the negatives there. And if you do have any questions, please let me know. But other than that, thank you for watching and good luck on your homework.